done with the gases part of the gases part of topic 4. Now we are going to discuss on the liquid. So in fact, yesterday we have discussed the earlier part of the liquid. Okay, right. So first you have been introduced to the type of solution. Okay, so the type of solution, we have two types of solution. One is solution with non-volatile solute. The other one is the solution with volatile solute. So solution with non-volatile solute means the solute will not vaporize to the upper phase of the solution. Only the solvent will vaporize. Okay, for solution with volatile solute, both of solvent and solute will be vaporized in the upper phase of the solution. Okay, right. And then you have been introduced to vapor pressure, the law. Okay, the law for vapor pressure. So it is known as Raoult's law. Okay, so this is the formula for Raoult's law. Okay, so it is PA. In this case is the vapor pressure or partial pressure of component A above the solution. So the one that vaporized. Okay, the one that is the one that can vaporize to the upper phase. Okay, if we are talking about the non-volatile solute in the solution, that means the solvent will vaporize. Only the solvent will vaporize. Tapi if we are talking about solution having volatile solute, okay, that means we would have this one for solute and the other one for the same formula for solute and for solvent. Okay, so it should be the total partial pressure for solute and solvent. Okay, right. Ataupun sometimes PA ni, in general kita kata component A above the solution. So component yang vaporize. Okay, right. So normally yang vaporize will be solvent lah. Okay, alright. Kadang-kadang soalan bagi formula, okay, you may refer from your reference book. Sometimes dia bagi PA, sometimes dia bagi P solvent, sometimes okay dia guna solution. Okay, for non-volatile solute. For non-volatile solute. Yes. Banyak sangat term nak kena pakai dalam satu masa. Jadi macam dia cacar marba sikit. So sometimes dia guna apa dia represent sebagai unknown. Okay, sometimes dia label solvent, sometimes solution. But you should know, okay, when it involve a non-volatile solute, okay, only the solvent will vaporize. So dia pakai solvent ke, solution ke, doesn't matter sebab you kena tahu yang naik hanyalah solvent. Okay, the one that easily vaporize, that can vaporize lah basically, because non-volatile solute will not vaporize at all at normal punya condition lah. Okay, unless kita bagi very extreme condition, then mungkin dia vaporize. Tapi we are not talking about that. Okay, kita sekarang tengah discuss at normal condition. Okay, so usually macam sugar, glycerol, ethylene glycol, those are very viscous solute. At normal condition, it will not vaporize. Kalau kita panaskan at 200 degrees Celsius ke, then maybe dia boleh vaporize. But that is what I consider as extreme. Okay? Alright, so solution with non-volatile solute, we have also discussed this yesterday. Okay, tapi tak apa, kita go through. The non-volatile solute has no tendency to escape from the solution into the vapor phase. Okay, it reduces the number of solvent molecule per unit volume at the surface. Okay, cuba tengok diagram here. Okay, this is only the first diagram here represent only the solvent molecule. Okay, without the solute molecule, without the non-volatile solute. Okay, so yang atas ni akan easily vaporize. If, okay, we add in the non-volatile solute into the solvent, the thing about non-volatile solute ni, dia tak mau vaporize. Tapi dia dah occupy the space dia dah occupy the space yang initially patutnya solvent punya space. Yang ni, color purple ni. Supposedly solvent duduk dekat situ, but now dia dah occupy that space. Tapi dia tak nak vaporize. Okay, bila dia tak nak vaporize, we can predict that the number of solvent yang naik will be reduced. Okay, the number of solvent particle that can vaporize is now reduced. Sebab apa? Tempat tu dah kena ambil dengan non-volatile solute. Bila the number of solvent particle yang vaporize decrease, this also cause the vapor pressure to be decreased as well. Betul tak? Logiknya kalau dah dia tak nak naik and then particle solvent yang naik tu jadi sikit. Okay? Sebab dah tempat tu dah kena ambil dengan solute. So kalau yang naik tu sikit, yang naik jadi gas tu sikit, jadi vapor tu sikit, by right, the pressure that this particle can produce, okay, will also decrease. Berkurang lah. Okay? Compared to kalau dia without the solute. Cuba kira ada berapa dekat atas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ada 10 partikel. 1, 2, 3, 4, 5, 6, 7, 8. Macam mana boleh sama? Dia tak patut sama. Dia kalau nak lebih faham lah. Okay? Patutnya kalau nak tunjukkan dia lebih, dia patutnya kurang. Okay? Dia kena kurang dekat atas ni. Nak menunjukkan that the vapor pressure is decrease. Okay, sepatutnya mungkin ada 8 ke ataupun 7 ke. So it shows that the presence of non-volatile solute will cause the vapor pressure to reduce. So kat point number 3. Okay, so the tendency of the solvent molecule to escape from the surface decrease. Does this lower the vapor pressure of the solvent? Okay. Dia menyemak aja dekat situ, solute tu. Dia tak nak naik pun, dia menyemak dekat situ. Dan dia mengganggu orang lain yang nak vaporize. Okay, that is for the non-volatile solute. Okay, solution with volatile solute on the other hand, both solvent and solute will vaporize. So therefore, we have the P total. Betul tak? Kita ada the P total. So by using the Raoult's law, okay, we have the Raoult's law for component A, and we also have the Raoult's law for component B. Okay, and then when we total these two, we can get P total is equal to PA plus PB, which is this one lah. Okay, yang ni kita KIV dulu. Okay, saya nak check balik macam mana dia boleh end up Raoult's law for A is equal to Raoult's law for B. Okay, alright, so this is the representation of solution with volatile solute in terms of graph ataupun graphically. Okay, alright, so on the y-axis, okay, on the y-axis is the vapor pressure for A. Okay, on the y-axis yang lagi satu, okay, here, this is also y-axis. Okay, so this is the vapor pressure for B. So dia ada dua komponen kan, so we can represent both component by using the same graph. Tak payahlah kita nak buat graph lain-lain graph. Okay, we can represent them in the same graph. Okay, so we also have mole fraction dekat situ. Okay, mole fraction for A. Okay, mole fraction for A, kalau dekat paling kiri, dia adalah 1. Okay, kalau paling kanan, dia adalah 0. For mole fraction for B, paling kiri dia 0, paling kanan dia adalah 1. Okay, we know that mole fraction of A plus mole fraction of B is equal to 1. Sebab we are talking about mole fraction, betul tak? Mole fraction dalam solution tu. When we total these two, mole fraction adalah ratio ya. Dia adalah ratio of the component, mole of the component divided by the mole of, the total mole of the component in the solution. Okay, when we total up these two mole fraction, kita akan dapat 1. That's why dia ada 1 sebagai dia punya maximum. Okay, alright. So graph dia dekat sini. Cuba tengok graph dia dekat situ. Okay, kita start dengan A lah. So this is A kan, vapor pressure A. Dia punya apa nama tu, y-axis. So this is the graph. Okay, graph untuk A. That represent the vapor pressure. Okay, alright. So kita boleh predict. Let's see, kalau around here, apa nama tu, kalau around here lah, katakanlah this is like 0.8 katakanlah. Okay, 0.8 for A. Okay, 1 kepada 0. So this is like 0.8 for A. Kita boleh determine the vapor pressure. Kita pergi dekat situ and then we can check what is the vapor pressure for A. Okay, alright. So kalau A, the mole fraction is 0.8, that means the mole fraction for B should be 0.2, which is here also. Betul tak? 0.2. So ini B punya graph B. This is graph B yang ni, this one, yang green ni. Okay, so the mole fraction for B is 0.2. Okay, so what is the vapor pressure for 0.2 mole fraction of B? So kita boleh check dekat sini. Berapa? Okay, tu cara kita boleh baca dia punya graph. Contoh lagi sekali. Let's say kita nak check B 0.6 katakanlah, which is here kan. Around here lah. This is 0.6 for B. Okay, alright. So kita pun naikkan pergi kepada B. B mana? B this one. This one. Ni graf B 0.6 for B dekat situ. Okay, so kita boleh check on the vapor pressure for B. Berapa vapor pressure for B. Alright, if B, the mole fraction for B is 0.6, that means the mole fraction for A will be 0.4. Betul tak? Which is again dekat tempat dia kena dekat A tu. A tu mana? Kat sini kan? Dia nampak macam bertindih dekat situ So dekat A, right. So kat sini kita kena gigi kat sini. Dapatlah vapor pressure for A. Yang ni kalau yang tadi tu 0.4. Right? So itulah cara kita baca this graph. Okay, kita boleh dapatkan the information for A and B in the same graph. And then when we connect these two ends for A and B, so this is the A and this is the B punya end. So tak, dia punya ending dia dekat situ. When we connect these two dots, this line here represent the total vapor pressure. Okay, this one represent the total vapor pressure. That means kita boleh tahu, okay, katakanlah the total vapor, kita pakai, let's use blue, okay. So kita pick any point on the line tu, dekat atas line tu, katakanlah this point, okay. So let's check the total vapor pressure. Okay, the total vapor pressure, sorry, this is not, kita boleh tahu, kita boleh tahu dia punya mole fraction for A, mole fraction for B. Okay, so this would be the total vapor pressure dekat sini. It represents, so maksudnya kita boleh check and then kita boleh totalkan, boleh je, kita boleh totalkan. Okay, tapi from here, we will be able to determine the mole fraction at, katakanlah total pressure something, berapa ni pakai torr ke, katakanlah kita nak tahu total vapor pressure of 100 torr, berapakah mole fraction for A and B. So kita katakan this point kat sini, kita going down, kita akan jumpa A kan, so that would be the apa nama tu, that would be the mole fraction for A. Kita going down, kita dapat mole fraction for A berapa kat sini. Okay, going down further kita jumpa B, so kita ke bawah lagi kita dapat the mole fraction for B. Okay, in fact kita boleh cari dia punya vapor pressure and then totalkan, kita boleh tahu the total vapor pressure. It is the same as this one, dekat atas line ni. Okay, alright, itu just nak bagi you idea lah. Okay, kita boleh plot a graph for this ideal solution ataupun solution with volatile solute, right? Okay, example, let's look at an example. Calculate the vapor pressure of water in a solution prepared by mixing 99.5 gram of sucrose with 300 ml of H2O, and then assume density of water is 1 gram per liter. Okay, so first you have to identify the type of solution given. So this is, so the solute given is sucrose. So this is what type of solution, guys?
Non-volatile.
Non-volatile.
Okay, all right, very good. So this is the non-volatile solution. Okay, it consists of non-volatile solute. Okay, maksudnya dekat situ terus bear in mind, oh, we have sucrose. Sucrose is a type of sugar, and it is very viscous. It is not going to vaporize. So the only thing yang vaporize will be the water. Water saja yang akan naik. So dekat upper phase tu will be we have particle of water in the upper phase. Therefore, the vapor pressure will be the vapor pressure of water lah. Sebab the water yang saja yang naik, yang vaporize. Okay, alright. So still kita akan pakai the Raoult's law. Okay, so P H2O in the solution, okay, is equal to mole fraction of H2O times P naught H2O. Okay, all right. So this one should be given in the question. So this is a constant. Okay, so the question should give out this information. All right. So next we need to have this mole fraction of H2O. Kita kena cari the mole fraction of H2O. So to get mole fraction of H2O, we know that mole fraction of H2O is equal to mole of H2O over mole of H2O plus mole of sucrose. Okay, that means we should have these two information. Kita kena ada mole H2O and mole sucrose. Okay, sucrose is not a problem because the mass is already given. So kita boleh cari the mole of sucrose. Okay, alright, so this is the mole of sucrose. Kita boleh cari mole of sucrose. And then how do we find the mole of water? Because as you can see from the question, the mass of water is not given. Instead, dia bagi volume dekat situ and also density. Okay, dia bagi density. But in order to find mole, kita kena ada mass. Okay, tapi tak apa because we have the density. So we can convert the mil, the volume into gram, and then from gram, kita boleh divide by the molar mass in order to find the mole of water. Okay, alright, so to find the mole of water, okay, 300 ml, so this is given. Okay, so bawah kena ml of water jugalah. Okay, so this, for this one, the conversion factor, we use the density given, gram per liter. Okay, so given is in gram per liter. So saya convert straight away. Liter, in this case 1 liter will be 1000 ml. Okay, so saya tak payahlah nak buat dia punya conversion sebab saya terus convert dalam kepala kan. So 1 liter is also the same as 1000 ml. So atas sini should be 1 gram of water. Okay, alright, cancel out. Therefore kita ada gram. We have the value in gram. So bawah here should be gram of water. So it should be the molar mass lah. Okay, because we want it to be in mole. 18. So up here should be mole of water. Okay, so you will have the mole of water, which is 16.65 mole water. Okay, gram cancel with gram. Alright, so we have the mole of water, we have the mole of sucrose. Okay, so we can find out the mole fraction of water. Okay, and then we have that already. So kita dah mole fraction, so kita dapat 0.98. Kita masukkan dalam Raoult's law formula. Okay, all right. So we have this as our final answer. Okay, so the unit should be the unit of the pressure. Okay, all right. In this subtopic, kita tak insist that it should be in ATM. After all, we do not have R. Kita tak ada constant kat sini yang mewajibkan kita mengguna certain unit for the pressure. Okay, so we may use any unit lah. It depends on the question lah. Okay, if the question give out the question use torr as the unit for pressure, that means you can just straight away use torr. You don't have to convert unless otherwise stated. Maksudnya soalan nak give the pressure in ATM. Okay, dan baru kena you tukar. Kalau tak, you pakai apa yang ada dalam soalan. MMHC ke, torr ke, ATM ke, tak kisah. Okay, alright. So this is the unit for the pressure. So as you can see, mole fraction does not have unit. Okay, mole fraction does not have unit. Dia tak ada unit sebab dia cancel out. Mole kena cancel dengan ni kan. Dia punya unit kalau kita factorize dia adalah mole. So mole cancel. That's why dia adalah ratio. Okay, that's why dia tak ada unit dekat situ. Jangan mole fraction ada pula mole dekat situ. Okay, that's why we end up with torr dekat situ sahaja. Okay, alright. Another example, calculate the total vapor pressure of an ideal solution made by mixing 0.5 mole of ether and 0.25 mole of ethanol. Okay, so these two are volatile, solute and solvent. And then one more thing, you kena aware that ideal solution means both solute and solvent are volatile. All the component ataupun both component are volatile. Okay, bila dia bagi term-term macam ni, you kena pandai baca. Sometimes you pun tak tahu whether the given compound tu adalah volatile ke non-volatile. So term-term macam ni, it helps us to determine whether dia volatile or non-volatile. Okay, alright. So bila dia cakap ideal solution dekat sini, kita straight away tahu that dia volatile, both of them volatile. That means kita akan ada P total. Okay, kalau katakanlah soalan dia tak cakap total vapor pressure kan, dia kata calculate the vapor pressure of an ideal solution. So it is understood. You kena tahu sendiri that it should be the P total. Okay, so at the end you should be calculating for the P total. Okay, alright. So for P total, we should have more fraction of ethanol times P naught of ethanol tambah more fraction of ether, okay, times P naught of ether. Okay, macam biasa you kena cari. So these two constants should be given in the question. So you punya kerja is to find out the mole fraction of ethanol and mole fraction of ether. As you can see, soalan dah bagi dah dalam bentuk mole siap-siap. Apa lagi yang nak susahkan hidup? Terus je lah cari. Okay, this is a mole fraction of ether and this is a mole fraction of ethanol. Terus je darabkan dengan P naught, so you dapat and then you total up. Okay, alright. So let's write out this checkpoint 17. Okay, cuba buat guys. Saya bagi 2 minit, okay? Alright, jom. Let's discuss the answer. Uh, let's go through the question first. Calculate the total vapor pressure of a solution made by dissolving 25 gram of glucose in 215 gram of water at 50 degrees Celsius. Okay, alright. So glucose is also one type of non-volatile solute. Glucose is a type of sugar. Okay, so it is very viscous. So dia kita consider as non-volatile solute. Okay, alright. Even though dia cakap dekat sini calculate the total vapor pressure kan, total vapor pressure. So you kena tahu, okay, bila dia evaporate tu, only the water will vaporize kan. So there's no solute ataupun there's no glucose in the upper phase of the solution. That means the total vapor pressure is also the same as the P water. Okay, total vapor pressure is also the same of P water. So jangan rely sangat menggunakan total vapor pressure ni. Bila ingat total, mesti ada dia adalah hasil tambah. Not necessarily. You define what total is. You subject to your ni lah soalan tu. Okay, yang ni pun tadi soalan ni dia pakai total vapor pressure kan. This one also dia pakai total vapor pressure. Tapi for this time around, only the water that vaporize, not the solution, not the solute. Okay, so you define. So jangan get apa orang kata stuck lah dengan tapi dia cakap total vapor pressure, then it should be a total of something lah kan. Not necessarily. Okay, you define apakah total vapor pressure tu. So P total, since this involve non-volatile solute, that means water, only water that vaporize. That means P total is equal to pressure of water, vapor pressure of water only. Okay, alright. So macam biasa, kita pakai more fraction Raoult's law, dia tetap dia ideal solution ke, volatile solute, non-volatile solute ke, we still going to be using the Raoult's law. Okay, alright. So H2O, P naught, H2. So carilah H2O. So dia dah bagi dah in gram kan. So this is for the solute and this is for the water. Okay, alright. So cari. So you prepare, this is for H2O, this is for glucose, so this is to find the mole fraction of H2O and then later insert into the Raoult's law, you have the final vapor pressure of the solvent. Okay, alright. Moving on. Okay, because glucose is non-volatile, the total vapor pressure is the same as vapor pressure of water. Okay, like I said just now. Okay, alright, so kita postpone this checkpoint. So this is your homework. Okay, we'll discuss all the checkpoint during our next lecture. Okay, alright, so kita hold on to that first. Moving on, the vapor pressure lowering. Okay, alright, kita dah go on to the, kita dah start to discuss on the colligative properties, remember? So we have 3 colligative properties. Okay, these 3 colligative properties are caused by the presence of solute in the solution. Okay, so kehadiran solute dalam solution ni boleh menyebabkan merendahkan vapor pressure. Kedua, meninggikan boiling point. Ketiga, merendahkan ataupun depress the freezing point. Okay, so now kita akan start dengan vapor pressure lowering. Tadi bezanya just nak tahu vapor pressure. Okay, now kita nak tahu vapor pressure lowering. Bila cakap lowering maksudnya penurunan. Mesti ada before and after. Sebab lowering kan kita kena tahu daripada initially berapa and then after berapa. Then baru kita panggil dia lowering. Betul tak? So it can be represented as delta P. Change in pressure. Change in vapor pressure. Okay? Alright, so this vapor pressure lowering depends on the mole fraction of the solute. The more solute present, the greater is the lowering. That means, can you imagine kalau banyak solute present in the solution? So what happened to the vapor pressure? Okay, so the vapor pressure will be reduced further. Okay, lagi banyak non-volatile solute present in the solution, the more the vapor pressure become even more decrease. Okay, alright, so how do we find delta P? So the easiest way will be delta P is equal to P naught A. Naught is the pure version, maksudnya without the solute. Okay, minus PA. Ini kalau dalam solution. Okay, dalam solution. PA ini maksudnya dalam solution. This one without solute, maksudnya only the solvent present. This is when in the solution, only the solvent vaporize. Okay, PA so jangan confuse ni, PA dalam Raoult's law kita tu benda yang sama, yang component that vaporize. Ini the easiest way, tapi normally soalan tak bagi sedirect macam ni lah. You can just simply minus. Dia mesti you akan ada kena kerja sikit. You have to do some working first, okay, so that you can just simply minus and then get the delta P, right? Or, so this is our first alternative. Okay, it depends on what information given in the question. Alternatively, okay, kita boleh derive kita boleh cari delta P dengan menggunakan satu formula. Formula dia dekat bawah ni. This is the second version lah. Okay, second version. Maksudnya kita boleh guna yang the first one and also the second one in order to find the delta P ataupun the vapor pressure lowering. Okay, sekarang ni nak cerita how, okay, at the end kita dapat this formula. Macam mana kita boleh dapat this formula dekat sini? Okay, dia sebenarnya start daripada Raoult's law itself. This is Raoult's law, betul tak? Okay, let's say this is our first equation. Okay, alright. Secondly, we know that mole fraction of A plus mole fraction of B is equal to 1. Ini bukan something yang kita ada-adakan. Ini memang dia punya relationship dia. Okay, the mole fraction of A plus mole fraction of B is equal to 1. Kalau kita ada banyak pun komponen XA, XB plus XC plus XD, okay, the total will be equal to 1 juga. Sebab dia ratio kan, ratio dalam keseluruhan. Okay, so the total dia still sama dengan 1. So since kita ada solute and solvent saja, A dengan B, that's why XA plus XB. Solute and solvent, for example. Okay, alright, so it's equal to 1. So this is a mole fraction punya relationship. Okay, alright, so we can rearrange this. We can rearrange XA plus XB is equal to 1 into this. Sebab apa? Sebab kita punya reference will be our Raoult's law kan. Raoult's law, kita ada XA. Okay, so that's why kita rearrange this mole fraction relationship into this one. So this will be our second equation. Okay, alright, so next we can substitute number 2 into 1. Masukkan number 2 into 1, kita akan dapat begini, betul tak? Okay, alright, so kita boleh selesaikan this one kalau kita darab masuk each one of them. Okay, kita darab masuk and then we rearrange dia balik, kita akan dapat begini. Okay, this one kalau saya darab masuk kan, cuba saya tunjuk. PA is equal to P naught A tolak mole fraction B times P naught A. Kalau saya darab masuk this one. Okay, so kita rearrange so that kita boleh dapat sama macam our first formula yang simple ni. Okay, so how do we rearrange that? Okay, kita pindah to the other side. Kalau kita pindah this side, okay, kita akan dapat PA minus P naught A XB P naught A. Okay, kita akan dapat macam ni kan. Tapi kita rearrange lah. Kita rearrange so that ini kita tak ada negatif. Okay, kita tak ada negatif. So this one kita transfer kita transfer in front of PA so that kita boleh cancel out the negative. Okay, so P naught A minus PA dapat XB P naught B. Which is ni lah, yang sama benda yang sama yang saya tunjuk ni. Bukan ke ini sama dengan this one? Sama kan? Alright, so we can say that this is also can be represented as delta P. XB bukan ni A XB P naught E. Okay, alright. So to find vapor pressure lowering, we have two ways. One is by using delta P, P naught A minus PA. The other one is delta P, a mole fraction of B or the solute times P naught E. Okay, alright. Let's look at the example. The equilibrium vapor pressure of water is 60 degrees Celsius, and this is the vapor pressure of water. Okay, all right. So please take note that this one is the P naught H2O. Macam mana kita tahu this one is the P naught H2O? Because dia kata the equilibrium vapor pressure of water only for the water. Maksudnya dia tak mention the solute ataupun solution. That means we can assume that this one is the vapor pressure of water. That means it is the pure water. Okay, P naught of H2O. Okay, you kena make sure you pandai nak translate information yang dia bagi tu into apa term-term yang ada in the formula. Okay, kalau you salah translate, that means you akan confused lah dekat situ. Okay, calculate the vapor pressure lowering. Dekat sini dia cakap vapor pressure lowering. Dia tak cakap vapor pressure. Kalau dia cakap vapor pressure, kita boleh guna Raoult's law. Sekarang ni dia cakap vapor pressure lowering. Ataupun nanti akan ada contoh-contoh ayat yang sama waktu dengannya. Dia tak semesti cakap vapor pressure lowering. Dia boleh cakap calculate the difference in blah blah blah. So difference tu is vapor pressure lowering, the change in P. Okay, alright. So for sugar solution where 30 gram of sugar was used to dissolve into 100 gram of water. Okay, alright. So kita ada dua cara kan. Satu, pure of H2O. In this case water kan, dia guna sebagai solvent. Minus PH2O in solution. Okay. This is the first alternative. Secondly, we can use XB P naught E. So both of this formula can also be used, okay, in this question. Boleh guna dua-dua. Okay, cuba tengok first. First one ni dia guna cara yang pertama, yang kedua or dekat situ dia guna cara kedua. Nampak ni? Mole fraction of the solute. Okay. Solute kita in this case B ataupun sugar times P naught H2O. Okay. Tapi sebelum nak dapatkan ni, you kena carilah mole fraction of sugar. So mole fraction of sugar dekat atas ni dia punya step dia. You cari mole and then you have to find the mole fraction. Okay. Alright. So dekat sini kalau you are using the first method which is this one, okay, you akan pakai Raoult's law juga dekat situ. Sebab PH2O, okay, tolak PH2O in the solution. So we are going to be using the Raoult's law. Betul tak? So it should be XA ataupun XH2O, okay, P naught H2O. Okay, so you nak pakai mana? You nak pakai mana-mana pun tak ada masalah. Okay, so ni misi mencari lah ni. Misi mencari yang ni sama ada you cari 0.0147, 1 tolak 0.0147. This is more sugar kan. Kita nak more water, kita nak more fraction of water kan. We can just simply minus lah to get the mole fraction of water. Okay, ataupun kita carilah untuk water siap-siap dekat atas ni. 11, the mole fraction of water over 0.166 plus 11.099. Okay, you still akan dapat 0.0. So bukan, you akan dapat something lah, value dia. Okay, so this one mole, cancel out. So you akan dapat more fraction of water and then terus masuk darab dengan 149.5. You still dapat the same answer. Okay, so it's up to you ataupun depends on the question. Macam ni obviously dia bagi banyak sangat information. That means you can use either of these two method. Sometimes soalan dia akan you kena choose satu saja. Dia bagi kurang information. That means you may need to use this one. Okay, only this method. This one you tak boleh pakai sebab the mole fraction of H2O is not given ke, mole ataupun water punya mass is not given ke, so you tak boleh pakai cara ni. Okay, dia depends. You kena tengok apa information yang given in the question. Okay, right. So we have one checkpoint 19. Again kita postpone. Okay, kita carry this one to our next lecture. Okay, berapa sana? Alright, so we are done with vapor pressure lowering. So now we are going to move to boiling point. Okay, boiling point elevation, kenaikan boiling point. But before we could do that, you have to know what boiling point is. You kena tahu apa itu boiling point. Normally you akan kata boiling point adalah temperature di mana liquid bertukar menjadi gas. Betul tak? Itu you punya statement definition for boiling point. Kalau layman, orang-orang biasa kata, macam mana tahu boiling point? Dia dah bubble tu boiling point lah. Okay, water tu dah kita panaskan, dia dah bubble macam orang gila tu kan. Tu boiling point lah tu. Okay, tapi you belajar science, you must be able to explain what boiling point is. What is boiling point? Okay, so boiling point adalah point kan, nama point kan. Point tu adalah dia fokus pada temperature. Okay, boiling point, satu temperature, specific temperature di mana a liquid boils at the temperature where the vapor pressure of the liquid equals to the external pressure or the prevailing atmospheric pressure. Okay, alright, so we have two types of boiling point. Boiling point dengan normal boiling point. They actually carries the same definition. Cuma normal ni kita fokus pada normal pressure. Okay, macam keadaan kita sekarang, normal pressure. Our normal pressure is 1 atm. Okay, siapa yang tak tahu, kita punya normal pressure is 1 atm. Right? Okay, so liquid boiling point adalah di mana vapor pressure of the solution is the same as the vapor pressure outside ataupun the external pressure. Okay, cuba imagine you boil water kan. Okay, ada water and then you kena cover lah. Okay, sebab you nak collect the vapor. You nak collect the vapor. You kena cover lah. Kalau you biarkan dia tu, you tak boleh nak collect the vapor kan. So, dia akan evaporate. Okay, so dia akan naik dekat atas tu. So this particle ataupun this vapor, dia produce pressure. Okay, so this internal pressure, okay, bila you panaskan tu, the more you heat, the more vapor produce. Betul tak? Lagi banyak vapor akan naik. So the more pressure will be produced. Okay, so sampai bila? Sampai di mana bila the pressure inside is the same as the pressure outside. That is what we call boiling point. Okay, pressure luar dalam sama dengan pressure luar. Itu kita panggil boiling point. Sebab mungkin banyaklah boiling point, dia depends pada ketika dia sama tu, itu dipanggil boiling point. Okay, alright. Normal boiling point pula, dia punya fokus dia adalah the boiling point of the liquid at 1 atm. Okay, that is the temperature at which the vapor pressure of the liquid is equal to an external pressure of 1 atm. Maksudnya bila kita panaskan kan, bila vapor pressure in the inside is 1 atm, which is the same as the P external. Bila dua ni sama, the temperature, okay, temperature at that time is what we call the normal boiling point. Normal boiling point. 1 atm dalam dah sama dengan luar, which also 1 atm. Itulah kita panggil normal boiling point. Di mana liquid bertukar menjadi gas. Gas tu menghasilkan pressure. Okay, pressure dia sama dengan dekat luar. Okay, which is 1 atm. Pressure dalam 1 atm, pressure luar 1 atm. Temperature itu dipanggil boiling point. Okay, alright. Okay, so boiling point and normal boiling point. So of course, okay, different substance will have different boiling point. Okay, alright. So for example, cuba tengok kat sini kita ada apa? Kita ada ether, kita ada ethanol, kita ada water. Okay, alright. So kita ada pressure versus temperature. Pressure, y-axis versus temperature. Okay, cuba kita tengok 760 torr. Kenapa 760 torr? Because 760 torr is also the same as 1 atm. This is at normal pressure. Okay, normal pressure. So, cuba kita tengok, kita going to the right. Okay, asalkan dia cecah aja dia punya graph tu, that would be the at 760 kena je dekat graph tu, so kita boleh check dia punya temperature. So what is the temperature, what is the boiling point, the normal boiling point for diethyl? It is 34.5. Sama juga kita nak go for ethanol kan. Okay, the moment dia cecah je ethanol tu, kita check dia punya. So it is 78.5. Okay, how about water? Kita further to the right. Okay, kita cecah je the graph line untuk water tu going down. Kita found out that it is 100 degrees Celsius. Okay, so the water boils at 100 degrees Celsius tu maksud dia apa? Pada ketika itu vapor pressure of the water is the same as the external pressure. Okay, which is 1 atm. Right, kenapa dia berbeza-beza kat sini? As you can see, why are they different in terms of normal boiling point? Mestilah ada kena-mengena dengan dia punya volatility. Okay, substance which are more volatile like diethyl ether has higher vapor pressure but lower boiling point because they have weaker intermolecular forces of attraction among liquid molecule. Therefore, less energy is needed for boiling. Okay, sebab dia punya intermolecular forces dia weaker. Senanglah dia nak escape from the surface tu, dia nak escape naik ke atas kan. So dia senang nak naik dekat atas. Sebab forces yang pegang dia tu weak. Okay, so it is easily vaporized. So kita panaskan sikit je, dia dah senang naik atas. Dia senang naik atas, that means it can produce the vapor pressure tu pada temperature yang rendah dah sama dengan external pressure. Okay, pada ketika in order to find, katakanlah 760 torr ni kena ada kena ada 100 particles dekat upper face. Okay, kat 170 torr mesti ada 100 particles dekat upper face to produce 760 torr vapor pressure. Okay, maksudnya untuk diethyl ether ni pada suhu dia 34.5 degree Celsius dia dah boleh produce 100 particles at the upper face. Okay, which is kita boleh kata that is already achieve the boiling point. Okay, the normal boiling point. Okay, it's due to weaker intermolecular forces. So water ni dia at 100 degrees Celsius, kita boleh kata water has stronger intermolecular forces sebab lama nak tunggu dia vaporize naik ke atas supaya dia eventually the vapor pressure in the inside tu sama dengan in the on the outside. Okay. So kita boleh kata the volatility and vapor pressure at T1 increase in the order water yang paling less volatile lah. Okay, less volatile. Dia susah nak vaporize. Then ethanol and then diethyl ether. Okay, this is in terms of volatility. Okay, alright. So of course kita akan ada calculation. So kita stop dekat sini dulu. Kita akan carry this one during our next lecture. Okay. Alright, so that is all for today's lecture. Any questions so far, guys?